Washing lines.
Right, well, good evening. Yes, my name's Chris Hall from Maidstone. I was originally a member of the YMCA Maidstone Club, but I'm afraid that packed up many years ago. And we used to have rallies and various other things, but that was in the heyday of radio. And I was also a member of West Kent Amateur Radio at Tonbridge, where I was chairman and vice chairman and various other things. But I then went and joined Cray Valley, and in fact Cray Valley have a membership of about 142, and it's amazing the different facets of radio that we get talking about. Anyway, various people have said Barmy. Well, you see, I live in Barming, which is just the other side of Maidstone, which, I don't know if you know the phrase to go barmy, obviously, but that's where the phrase barmy came from, Barming. We had the first big mental hospital in the country. So, and it's rather like somewhere up on the east coast, there's Bedlam, you know, when you go into a room and they say, oh, it was Bedlam. You know, but also just north of us is Rochester and the little village Borstal, so the first young offenders institution there. So, and another word to go barmy is, of course, you've gone loopy. Hence, loops. Oh, sorry.
To be honest, it sounds like politicians were trained.
Oh, yes, I'd go for that. Anyway, yes. So I've had an interest in, I mean, we all have amateur radios, but actually an amateur radio, and
Timber!
oh dear, oh, don't worry about that.
Oh no.
I didn't realise it would be this exciting.
Never do a live demo.
Oh.
Looks like it's broken.
It's broken. I'll come back. No, don't worry about it.
Still works. Tape.
No, I won't use that one then.
Yeah, throwaway devices. I'll come back to that. Wait, you stay there. Right. So I do believe in talking to equipment. It's far better. You get a sensible reply. Bother, I've lost it.
So that way, the different clubs you would actually go.
Oh yes, clubs. Yes, sorry. So yeah, member of Cray Valley, and lots of different facets. And that's what, in my opinion, modern amateur radio is all about. You know, whether it's Raynet or talking about the digital modes or whatever. Oh yes, and then of course, anyone who has a radio, you do need an antenna to go with it. And that is sort of somewhat fundamental. Some people have got acres of land where they can have, you know, 400-foot towers and enormous aerials, but most of us live in rural or sort of urban locations where we've got a physical limitation of the garden. So I've been playing around with aerials for some time, and one of my first, I'll call them, yeah, I'll call them, I would, come on. You move over there and then you won't fall any further. Right.
That's a good spot.
Yeah. One of the first ones I acquired was this wooden loop aerial. So it's basically constructed of hollow pieces of wood around the outside, hollow as in a channel that's covered, and then multiple coils of wire going round and round in circles. And it's got a couple of terminals on for binding posts, but in fact this one is, where is it, there it is, on the edge of it there's an inclinometer scale to give you an angle as to where it is. Now this was originally designed for the GPO to use when they were trying to locate cables. So you sent a signal down the cable and then you wandered along the road trying to find the cable, and when you went over it with an amplifier and a pair of headphones connected, you could actually hear when the signal, you know, was underneath you or off to one side. So that was an early loop, and a lot of very early radios in, you know, what should I say, 1920s, 30s, had a loop aerial not dissimilar to this. This is what, 3 foot square, so it's quite a decent size aerial. By the way, I'll try and explain, because obviously if you can't see what I'm demonstrating, I'll try and explain in words roughly what I'm holding, okay?
You're doing a good job so far, Chris.
Thank you, thank you. And, you know, it's beautifully built, a lovely varnish and everything else.
Is there a certain amount of windings in that frame?
The honest answer is, I've never taken this one apart.
Hmm.
I believe some of them had about 20 or 30 windings.
What's the advantage of loop aerials over other aerials and why?
I'll come to that in a moment. But then, of course, we get to other sorts of aerials. Now, with an old-fashioned medium wave receiver, I have a much smaller loop here. It's called an AM loop antenna, and it was the sort of thing that was attached to the back of a hi-fi tuner back in the 1960s, 70s. Small loop, what, 9 inches by 3, encased in plastic with a hole in the middle so it looks like a letterbox. And it hinged out of the back of the radio so you could get the right direction. Now this is the beauty of loop aerials. If I'm talking directly ahead of me and I look through the letterbox hole in the middle, it won't pick up anything. It's only when you're looking down the length of the loop, across the loop, from one end to the other, that's where it will pick things up. So think of it as a sort of, I'd say dipole or Yagi aerial, but it's all in one little loop, and it's very directional. It won't pick anything up when you look through the loop. And there are lots and lots of different styles of loop aerial, and we all remember the old, well, this is a Hacker radio that has quite a large ferrite aerial in, which is a rod with 3 or 4 coils on it. Now the whole point of loop aerials is some of them are connected directly to circuitry. A lot of them are not, because they are a loop aerial with a capacitor across said loop, and then a little loop that picks up the signal. So what you're really doing is tuning the big loop with its capacitor to a particular frequency, and then that will radiate very locally a much stronger signal than what's coming through the air. That's fine, and there are various different capacitors which I'll come to, but I mean this is a beautiful silver plated capacitor with great big vanes, and it has spacing of 1 or 2 millimeters between each of the vanes, because that one, you can also transmit using loops. However, there is one minor advantage with loops. They are, as I said, very directional, they're transportable, small space, that's fine. The worst part is they are very narrow bandwidth. So,
Is that your loop?
That's a cavalry
saved at last.
You're going to get the horses riding through the cavalry.
Saved at last.
That's it.
So anyway, yeah, very narrow bandwidth. So if you're going to tune a loop aerial, when you're transmitting, that's fine. But as you receive, you very carefully move the plates of the capacitor, preferably via a reduction drive, and all of a sudden you'll hear the noise come through of the frequency you want. But if you're transmitting very, very high voltages, and we're talking thousands of volts across the capacitor plates, that is why where is it? Oh, it's on. One of the loop aerials I've brought has what I would call a good old-fashioned air-spaced capacitor, which has very, very narrow plates. They're probably between one plate and the next. You can just about see an air gap, but you would not be able to use that for transmitting more than 5-10 watts. Anything more than that and it would flash over. And I have seen some of the capacitors flash over. It's quite spectacular. So I've got another bigger capacitor where the spacing is much better, and you can see the spacing is ideal. However, there is one other type of capacitor that is brilliant. It's called a vacuum capacitor. They go for an awful lot of money, but I found this one in a piece of equipment, and it's a glass envelope with a set of bellows one end and the capacitor plates the other. So as you wind it in and out, the bellows move backwards and forwards to give you continuity, but the plates actually go inside concentrically. And there are 4 or 5 different. Is it going to go that way? Oh, wait, no. Come on. So you wind it quite enthusiastically, and it comes away, and you can just see all the rings inside. So there's probably 10 concentric rings, and because it's a vacuum, it's unlikely that it will break down. It does say 10 kilovolts maximum voltage, but you can get 10 kilovolts quite easily on a loop aerial when you're transmitting.
So what sort of power would you need to get that sort of voltage?
20-30 watts?
Oh, really?
Oh yes, oh yes. So if you're playing with loop aerials, you don't touch them when you're transmitting.
So if you put a kilowatt down, it would be...
You would probably produce megavolts.
Really?
Oh yes.
Yeah.
And you know the old balls with sort of lightning. No, I don't mean lightning. What is it?
Yeah.
Tesla generator. And 2 balls and they spark between each other. That's the sort of thing that could quite easily happen. So if you're transmitting, put your hands behind your back or hold onto the microphone, but don't go near the area. Hence my caption that I've put up: be aware of loop antennas in transmit mode, danger, high voltage.
Why do they? Is it because of the way they're going through that capacitor and the fans that you've got there? Is it what creates that voltage?
Right.
In other words?
You are making, let me go back partly, right. What you're trying to do is I have a small transistor radio here with a bit of ferrite rod on it. And it's the same as the portable transistor radio that I was showing you. It's a ferrite rod, but it has 2 coils on it. One of them you are making into this resonant frequency or resonant circuit with a capacitor and a coil, and the other coil is picking up that resonant frequency. So it's quite broadband, but it's the resonant frequency loading, that's the wrong word, no.
Being concentrated, is that right?
Even that's the wrong word. No, it is, its resonant frequency is what makes it radiate to the pickup coil, and that is what is generating the high voltage. If you could measure the frequency of that very high voltage, it would only be on your receiving frequency. Do you see what I mean? I think that's the way it's...
Is it like the Q of a coil?
Exactly. Yeah, I'm sorry. Yes, that's it. Q of the coil.
Reactance or resistance?
Yes. Yeah. So it's you've got a very, very high Q, and there's, the peak goes way, way up and then comes back down again. But it's very narrow. But it's still bloody hurt if you touch it.
Well, it's like Tesla report energy
Oh,
up the
yeah.
air, didn't it?
Yes.
Yeah.
Yeah. And there are lots of different ways of making them. I mean, a ferrite rod is in fact a loop aerial, but it's sort of, it doesn't go round in a complete loop. It is just a piece of ferrite rod, but because you've got two coils on it, it acts in a very similar way. But it's the same as a transistor radio. You know, I was saying you have to point the coil in the right direction. It's the same as a good old-fashioned transistor radio has a circular base on the bottom that rotates, so you can put it on the table, turn the radio on and rotate it for the best reception. And that's why there's a turntable on the bottom of a transistor radio. Modern transistor radios haven't got it. So people put it on the shelf or something. Oh, it doesn't work very well. Well, that's because you haven't lined it up with the transmitter. You don't need to know where it is. You just twiddle the gadget round until you get a good signal. Because the audio that's coming out of the loudspeaker will fill the room anyway. Doesn't really matter which direction it's pointing in. But yes, so that's, you know, one of those things. Yes, if you are listening, if you select the frequency on your radio receiver and then tune the coil with your variable capacitor slowly, all of a sudden you will hear a dramatic increase in noise of the whole system of your loop aerial, and that will tell you that you are then resonant at that frequency because it's picking up noise from, you know, from the ether, and where the Q has all of a sudden dramatically jumped up to the frequency you want to listen to, that will then transfer across to your radio receiver. And hence why loop antennas like this one have a big coil and a little coil. So here's your resonant circuit with the capacitor in the box at the bottom, and there's the little pickup coil that you connect to your transmitter or receiver, as the case may be, depending on what you're trying to do.
I was watching a video with regarding, there was an engineering guy, electronics, and he was making an energy weapon with his sons. He was demonstrating the power. So is that sort of similar-ish where they're using the energy from one of those to...
Is it called a rail gun?
No, it wasn't a rail gun, no, this was homemade. They knew what they were doing of.
Yes.
And they could hold a fluorescent tube near it. It would light a fluorescent tube.
Oh yeah.
When they got to a certain distance, the tube wasn't connected, it was
Yes.
just picking it up from the air, you know, which was being generated.
Oh yes,
by-
but a cousin of mine used to live near Crystal Palace,
Yeah.
and literally you could go in the attic and hold a fluorescent tube, one end, and it would illuminate.
Really?
So there's that much radiated power.
Yeah.
Modern day, you'd call it electronic smog.
Mm.
But you know, yes, there is a tremendous amount of radiated power coming from a number of devices. I don't quite know what he was using as.
Yeah, I could look it up.
Yeah.
So is that, you're talking about with these loop aerials, there's a lot of radiated power capability?
I think yes, because you are transmitting in one direction. It's not an omnidirectional going all the way round. It is as good as a Yagi, let's say, you know, 10 element Yagi. And they are amazing things. I don't know if you heard me say earlier on, but a friend of mine who's got one of these aerials was on, his grandchildren live down in Hove, I think it is, and he was on the beach. And of course, water gives you a beautiful reflective source to jump on, to radiate from. But he was quite happily chatting to South Africa on his loop, on one of these loops. So they're amazing things. But, you know, you've only got to drift your frequency a little bit and you've got to retune it. It's very, very narrow. Yeah, so anyway. And it doesn't really matter whether the aerial is round, square, hexagonal, anything. As I said, if I just point up on the screen, you can see the equivalent circuit. You've got the tuned circuit with the bit there where you've got the variable capacitor and the coil, and then the little pickup coil which is next door to it, which that will pick up the circuit and go back to your transmitter or receiver. So you've got a primary loop and the secondary resonant loop, and the circumference is meant to be 1/10 of the wavelength, but that doesn't really matter.
What about the little one?
The little one, approximately 1/5 the size of the secondary loop. So this little loop is what, 8-9 inches across, and this one's what, a metre. Sorry, I know I'm mixing my inches in metric. You know what I mean. You can get the idea. And obviously, you know, there are a number of different types of loop. You can also use a loop for detecting radiated frequencies inside a bit of equipment. I have several. One which is a circle of copper, quite hefty copper, with a coax connector on the bottom, and that is about 9 inches across, quite well made copper. If I pass it forward and if you pass it down. It's mounted on a circular piece of printed circuit board with a coax socket in one place, and then it's attached to the printed circuit board. Someone gave me a piece of printed circuit board and I thought, I know what I can make that into. It keeps the coil nice and rigid. But if you're trying to look for the inside of a bit of equipment, it's quite good having just a little coil. And then there's an even smaller one.
Fascinating. Oh, thanks. Okay. So this is like a search call.
And literally a search coil, yes. So if you've got sort of the wrong
Very sorry.
harmonics coming out of something, you can connect it, and you can connect it to an oscilloscope or whatever you want.
Yes, connect.
So it's a BNC connector on the bottom, and then a little coil on top.
Slightly bigger for one that's got higher frequency.
Oh, a bit
Got that
wider.
hand over a second.
Yeah, good, yeah.
Yeah.
A bit wider.
What sort of frequency would that work at?
Oh. Probably 77s,
Okay.
something up, you know, 500 meg-ish, you know, somewhere up there. But it can be very useful. For instance, several of my other hobbies require radio microphones, one of which is 635 megahertz for UHF radio mics. So I want to be able to pick them up as well.
It's
But then comes the interesting one. I don't think they work that well, but the first one, these are what are called printed circuit aerials, which I think is quite clever. The first one is red, and that one is the AM antenna for medium wave. So it's, if you just put it on the seat, that's probably the best one. So this one is a circle of printed circuit board, but you can actually see the printed circuit track going round and round and round, probably about 10 times. And then down the bottom there is a capacitor that you can tune it to various frequencies, and then the connector at the bottom. And the next ones are very similar. So that one's the shortwave one. Same principle, coil, capacitor, a little coil in the printed circuit board as well, and then the connector at the bottom.
Have you, when you're not looking, have you ever had any young children dip them into the fairy liquid, bubbles?
No,
That's lost all your circuits.
that's evil, that is.
What does the switch do?
From memory, that switch, let me just have the read.
That's what you've got on your.
It is high and low, so it's 24 meg, sorry, 12 meg to 24 meg,
interesting.
or 4 meg to 12 meg.
Oh, I see.
That's what the switch does.
Yeah, I'm not
Yeah.
getting on with it.
I think it switches another capacitor in or something.
Does it matter about the amount of turns you've got on that on them?
For pickup on an oscilloscope or something, not really, you're just trying to have some pickup.
Yeah.
But these other printed circuit boards one, that one I think's got 20 circles.
Yeah.
This one is not quite as many. And then I've got two more. One is, that's 144 meg, so that's 2 metre. And again, it's very similar, but now it's only one turn.
You've got holes in them.
It's, yeah, cut away for lightness.
Oh, that's
That's the second loop, and with the connector at the bottom. Quite a few turns on it.
Oh, yes.
Yeah.
Yeah. Oh, well, that's
And then we go up to 77s.
got a second loop.
That's quite like that.
Oh yes, well, it's only a little printed circuit board, isn't it?
I'll make a halo for 20 minutes.
Oh, 1 or 2 watts? You're not really talking about. They're mainly receiving loops
Oh, right.
for use with one of these little mini.
Yeah.
Right. I'm going to fail because I haven't. No.
There's a small one.
Yeah. But they're all very similar. So it's a piece of printed circuit board with a loop on. These last two only have one loop, one turn. But you've still got the little capacitor and a connector down the bottom connected to another little loop. But they're quite clever. I have tried making a couple of loops, one with central heating pipe, or water pipe, the sort of thing that feeds the ordinary taps. And I was trying to make a loop. The other thing you may have seen is 2 crossed loops on top of Coast Guards or whatever, and there are 2, and you're meant to be. I don't quite understand how they work, but it's along the lines of you can null out to a particular signal, and then say that's where the transmitter is coming from, which is quite interesting. But the other one I've just acquired. Oh, come on. Now this is another little. This is a loop of brass or copper, I should say. But its feed. This is meant for transmitting. Its feed point is on a much smaller. It hasn't got a separate loop. It's got a gamma match, so that the connection goes up and goes partly round the loop before it joins the main copper loop. But if you can.
It looks like a magnifying glass.
It does look like a magnifying glass, yes.
Are these loop aerials Earth?
Something like that. This big one, no. So your secondary loop is totally separate from anything else. I suppose. I think that one is because its gamma feed point is connected to the coil. So yes, it will be. I mean. Why does it need to be connected to Earth?
Well, I was just thinking radio waves and the way they shoot all over the place. So I wondered if there was any benefit in grounding them.
No, I don't think so.
No?
I mean,
Whether it created a bit more stability or whatever it was. Because you know how you can get dirty electricity?
Yes.
Yeah, and that can change at whatever
Oh, yeah.
point in the ground it is.
Oh yeah.
So that's why I wondered if you could get the same sort of thing in the air.
The other thing is, you do not need to operate a coil from a high elevation. It will work literally on the ground, 2 or 3 feet off the ground. So you don't have to have 40-foot tower and all the bits on top. And in fact, a friend of mine has one of these, and literally he's got sort of 2 or 3 broom poles that, no, they're not broom poles, but, oh I know, the sort of thing you'd wash the windows with upstairs, do you know what I mean, an extending pole. He's got one of those, and he mounted this on the top. It made no difference whatsoever, but what he wanted it for was a small sort of dipole or something that he could push up in the air. And in fact, this is far more sensitive than just a straight dipole. It's equivalent to about a 4 or 5 section Yagi. And it's highly directional, as you can move the loop around.
But presumably you'd have to keep that away from walls and things, because presumably it would detune quite easily, wouldn't it?
Yes, yes. Ideally, it's in the middle of a grassed lawn. Or as I said, the man who went down to Hove, he was on a clear beach. But if you're on a beach, you've got to be careful that the kids don't come around saying, "Oh, look, what's that?" keep other kids or other people away. Mind you, I suppose I could say it. You put one of these on the beach, and there's the inflatable landing craft come on board with lots of unrequired people. Come on, do touch this. Stop it. Stop it.
Or if you want a free perm.
Free Einstein with his hair standing on end. Yes.
You're giving Tanya ideas there.
Stop it.
No, I've got curly. I don't need any more.
But of
Oh, we
course,
didn't mean for you.
if anybody wants any ribbon cable to play with, please take some. But also you can get things like SCART cable, and that's ribbon cable as well. So there's lots of ways you can obtain, you know, devious ways of getting your loop. What else was it? Oh yes, I suppose Eddystone are the best people for capacitor, or used to be the best people for capacitors. But if you're running a loop, what you don't really want is, there's a capacitor here with fixed plates and the variable plates that move out from between the fixed ones. But in an ideal world, you don't want fixed, you want what are called butterfly capacitors, where there are two sets of stator plates, are there? Stator plates, that are the fixed ones, and then two other ones which are variable, that mesh with the stator plates. So if I pass this one round, don't get your fingers caught. As you turn it, it could trap them, but you can see what I mean. But it's called, because of the central bit that moves, looks like a pair of butterfly wings, that's why it's called a butterfly capacitor.
Why is that better than?
Why is it better? Because it is more balanced, I think is the answer.
That's the other piece. If you just, on the edge, if I slightly turn that,
But don't trap her
if
fingers,
you
please.
touch it just there, and you can just feel the,
Yeah.
But you can feel the same
looks
both
like a bow
sides.
tie,
Yeah.
and the state
Yeah.
doesn't look like another bow tie.
Yeah, but bow tie is another
Yeah.
word for them, yes. And of course my big loop aerial, which was made of this ribbon cable, is on a stand. Sadly the connectors have broken, but that's, they've been stored in the garage, and I think they've just suffered from metal fatigue. But by having a loop like that, you need it on a non-metallic frame. So you've got this one is a wooden frame that packs up quite easily, and the one that's the commercially made version is on plastic tubing, and it uses RG213 as the loop, all nicely gold plated and what have you. Doesn't matter what shape your loop is in, whether you make it a copper heating pipe or cable or whatever, there's lots of different ways of doing it.
Just a stupid question.
Go on.
If you laid it down flat,
Yes.
would that then be on me?
Yes, that is, yes, it is. But if you lay it flat, yes, it's on me, but it removes the directional properties, so you can't eliminate QRM interference from anywhere.
So you're giving up what you.
So one of the good things about this is, if you've got your neighbour who's got, I don't know, a Duff battery charger or something, which is continuously whining at you over quite a wide frequency band, you can then move the loop round until you get rid of it, so that the flat face of the loop is pointing to them, and you can carry on. But there's an awful lot of suspect electronics out there that is radiating
40
something.
metres.
Yes, have you discovered what the source is?
Not as yet, no.
Not as yet, oh dear, yes. But of course that is also where those little coils that I was showing you are very useful, mounted on the top of a handheld, and you can wander around and see where it comes and point it in the right direction, and then talk nicely to your neighbour or whatever, saying, we have a problem, please could I come and investigate? So long as you're not, oh, turn the bloody thing off, you call it, you know, you've got to be gently. But there is an awful lot of interference out there. Yes, but that's life, I'm afraid. Oh, so there's a picture of my one of the vacuum capacitors mounted with the top and bottom of the vacuum part of the capacitor is actually part of the loop going all the way round, and usually you have an isolated rod that goes down to the bottom of the loop with the motor at the bottom, so that's well clear of the loop. And obviously you need to make sure that it's, again, the very high voltage, if you bolt the motor to the bottom of a very high voltage loop, it's going to get, I'll call it, infected with high voltage, and it could easily burn out some of the coils within the motor, so it really wants to be well below.
Because you said you was around Maidstone area, didn't you? So as you come down from the Medway, it tends to travel down the land, doesn't it?
Right.
Then you go into the Weald of Kent.
Yes.
So were there any advantages of using loop aerials there? Because you've got more obstacles, you haven't got line of sight so easily, have you?
It still helps if you're on top of a hill, albeit on the ground, 3 or 4 feet off the ground. If you are in a valley, you are subject to normal RF conditions, in the fact that if you're in a hole, you've got to dig yourself out of it, yeah, don't buy a house in a valley. It'd be all right on Romney Marsh, something like that, which is flat, even though there's hills a little way away. Once you're 3 or 4 miles away from a hill, not mountain, just a gentle hill, the RF seems to go over it reasonably well. I mean, from where I am, I'm on the top of a ridge, but it goes down into the Maidstone Valley and then up over to the Bluebell Hill. But my radio signals jump over Bluebell Hill quite happily into Essex and further. And this is on 2 metres.
Like skimming stones.
Yes, something similar, yeah. What else have we got? Oh yes, if you're trying to make your loop bigger, there's several ways of doing it. One of it is this particular aerial is a commercial beast, but it's made of a strip of aluminium bent quite cleverly, very close together waves, so it goes up and down, up and down, up and down, probably maybe even 30 or 40 times in the space of a 6-foot loop. So you've got a tremendously big loop, but it's been compressed, been compacted, which is quite a clever way of doing it. And there's the secondary loop below, just to pick up the bits. But as it's a commercial one, you're talking quite a lot of money. And it doesn't matter if your loop is even bigger for HF. I've got one here which is a picture of a house with a tree and quite a large mast adjacent to the house, and then a straight piece of wire from the top of the mast to the top of the tree, and then the 2 ends come down to a ballon, so you are in fact causing a triangular loop. It's not upside down, but horizontal top, 2 coming down to the bottom where the ballon is, and again that's a loop, so you're picking up an even better signal. But obviously if it's attached to the house and a tree, it's very directional, and you won't be able to swing it round unless it's very windy and the tree bends. And there are other different ways you can have various loops. Yes, you can have horizontal loops. There's one there which comes from the top of the house going to one tree, goes across to another tree, and then back to the house. So there are lots of different ways of experimenting, and whichever one suits you, go for that one.
Now on those bigger loops, like
Yeah.
the delta loop that you showed us, would that have the primary and secondary, or would it just be
No, I think it is just a loop.
just the loop? Yeah.
I won't say it's not. It's not using the same resonant technology as having a high Q. It's just a loop, preferably. I don't quite know how you get match, or you'd obviously have to go through an ATU or something.
No.
But I would think, unless it's of the correct size, you're going to get a bit of mismatch.
Yeah. So that wouldn't be a high Q.
I don't know.
No.
You can touch that one without it hurting.
Yeah.
Oh yes, and there's the little mini loop that I had attached to a handheld with its little gamma match down the side, and it's that one is very useful for picking up interference. Let's say at 144 meg, because you can wander around the estate and people think you're looking for a UFO or something, but you know, if you've got a really big loop like this and you put that on a rucksack or something, they really will start asking questions. And again, oh yes, that one, you can have a really big square loop, but each side has got to be a quarter of the wavelength if you want it to be a good aerial at the right frequency. As I said, this requires some real estate. You get some of the big American people who've got it. Having said that, BRATS, the Bredhurst Amateur Receiving Society, I think it is, up at top of, where is it? Bredhurst. They have a farmer's field, and they've got 4 enormous scaffold pipes on the 4 corners, and they've run it right the way round the corner of the field, and that makes for a superb aerial. Obviously it goes through a ATU to get your frequency resonant, or to get the matching correct, but basically there's a lovely big square antenna, but you need the real estate to do it. Not many people, I mean, it's probably what, 3, maybe 4 acres, so not many people have a 4-acre garden. More like postage stamps now. First of all, the Alex loop, which is this one, it's a very good compact one, comes in a little bag, and they now cost just over £400. When I bought this one, it was down at 200, which was enough at the time. But they are a commercial product, very good and easily transportable. We do have some other ones. MFJ, oh yes, we all know MFJ. Sad that they have stopped manufacture, but I'm sure you can pick them up on various rallies and things. But they have this enormous plastic enclosure which takes all the electronics and everything else. Hello, who's woken up? Oh yes, then we have a Cairo Stealth magnetic loop. Their adverts always show this particular magnetic loop, which is a weird and wonderful, it seems to be almost, what should I say? What does it look like?
Carjack?
A scissor carjack, that's the word, yes. But you're talking £1,200–1,300 for it. But it's got quite a clever thing at the top, which is where your variable capacitor is. You know what a multi-finned heatsink looks like? Well, this is rather like 2 multi-heat sinks that mesh together, and that gives you your capacity, which is quite clever. But that one, the advert for this one is when it's bolted on top of a balcony on a block of flats, which is, you know, nobody really knows what it is. It's about, what, 3 foot long, so it's quite a hell of a carjack. But, you know, people wouldn't know that it was an aerial unless you're interfering with next door neighbour's television. Oh, this is another one which is made out of, I think it's 1 inch or even 2 inch aluminium tube with the same meshing arrangement on top. But again, you're now talking, and these prices are not up to date, they're about £2,000. But if that's all the space you've got and you want a decent aerial, they're brilliant, but it'll cost you. What else have we got? Oh yes, there we are. There's the, I'll say, the heat sinks that are unmeshed and they're pulled apart. And then it's quite a clever way of doing it. They've got a motor mounted right in the middle that just pushes out both sides, and that's how you get the meshing in. It's clever. But I can't stress enough that if you're transmitting on one of these things, don't touch. It will hurt.
Has anyone ever been killed or badly injured from the voltage?
No, I don't think you get RF burns. But obviously, even if you, well, you see, the Alex loop here is RG213, which is covered in plastic. It's only when the metal connectors down the bottom that, again, produce the voltage. None known of. But obviously they might not actually know that you've just been killed by a loop aerial because there's no signs of damage. He just fell over and his heart stopped, you know. Yeah, don't go down that road, I think I'd say. Right, has anybody got any more questions? I think I've covered most eventualities. Yes, sir. Hang on. Yes, sir.
Cardioid loops.
Cardioid loops.
Any experience?
What is your definition of a cardioid loop?
In order to use it for directional purposes?
Well, yes, but this is, I think, is a cardioid loop just specifying the radiation pattern? Because this has a cardioid pattern, but I don't quite know what you mean by a cardioid loop.
You're able to switch the direction of that loop as opposed to...
Ah, right. I think
change.
that might be the one where I was talking of having two loops at right angles and you can spin them round as seen on the top of Coast Guard boats and various other things for direction finding. I think that's it.
Is that like when you get cardio microphones?
No, that's something
different
Yeah.
principle.
Yeah, that, as you say, I know about cardioid microphones, but I think it's the standard, I'll call it Ministry of Defence type aerial, which has two loops at right angles, and by having a receiver on both, and you have the ability to tune it, not tune it, balance it. That's probably the word. You can get the phase right, so you have a fixed aerial, but you can move this control around, and I'm not quite certain what it does. But there's two coax cables coming down from this crossed loop, and you can steer where your receiving signal is coming from. I think that's what you mean. I don't know of anything else.
Mobius loops?
Mobius?
Or
Mobius.
screened as opposed to unscreened.
Right. Yes. One of them is where you have a coax cable on both sides, but at the top they are reversed. And you know, a Mobius piece of paper is a continual loop. Continual loop, yes. But you've put a twist in it halfway round. So although you go round on one side, when you come to go round the second time, you're on the other side. So yeah, think of a strip of paper, inch wide, 2 foot long, join the ends together, only as you join them, you've turned one through 180 degrees. That's your Mobius loop. And I think that's what you mean by having a coax Mobius loop, in the fact that you have a piece of coax cable going up to the top. Where it is at the top, you change the centre and the outside screen over, so that gives you your, I would call it Mobius loop. And what was the other one?
Screened versus unscreened, where your conductor is screened but with a gap at the top.
Yes, yes. You can do something very similar, and instead of reversing it, you just cut away the sheath. And now what's that one? That is where you pick up, I want to say the H field or something. I can't remember the...
Some discussion about that.
Yes. It's along the lines of it. I can't remember the words. It's along the lines of you get rid of a lot of interference and you're only dealing with the frequency you want. I'm not familiar. I know exactly what you're talking about, but I haven't read the book far enough.
Balances out the voltage, so you just get the mag field.
That's it. Something like that. Yes. Yeah. So you're looking for the magnetic field and not the
Voltage.
or not the voltage. Yeah. No, there's another name for it, isn't there?
Electrostatic.
Yeah, that do.
That'll do. Yes, that'll do. Yes. Yes. H and E fields are not my forte, but yes. Right. Has anybody else got any more
So,
questions? Go on. Sorry.
When you have a dipole,
Yes.
you get quite high voltages on the end, don't you? Because
Yes.
there's no way for the current to go.
Yes.
So, and I mean, one way of checking that you're transmitting is to put your finger on the end of the dipole and see if it
Yes.
sparks. Like
But
it
you're
used to
not. You're not tuning the dipole to radiate power. Yes, you are.
be. Well, you sort of are, but I mean, the question was really, you said a lot about high voltages. I mean, would that bite harder than
Oh yes.
a resonant dipole?
Oh yes. Because
so it is a serious
oh yes.
consideration.
Because although on a dipole, it's okay. You're transmitting 10 watts, let's say, and the voltage at each end is going to be, I don't know, 30 volts or something. You know, that's peanuts. But with this, you are talking of hundreds, if not thousands, of volts. Now, why? And that's why you need these high voltage capacitors. Otherwise, it will break down and spark. Now, that's sort of the. I was going to say that's the theory. You are making a resonant circuit with a very, very high Q, whereas a dipole is a relatively broadband aerial, isn't it?
Yeah.
You know, okay, you think it's a 2 metre,
Yeah.
but in fact it works from 120 up to 170 or something.
So suppose you're using one of those on 40 metres then, I mean, what sort of bandwidth would you get out of it?
Not a lot. You're talking 3 kilohertz if you're lucky, or if you, I think the higher, lower, I can't remember which. Sometimes you've basically got to go CW and the bandwidth comes right down to maybe 150 hertz.
Which would be good for CW.
Oh yes, yeah, so it's brilliant.
If it's stable.
Yeah, but it seems to be stable, but you've got this tremendous Q, which is where the voltage comes from, where you don't have, on a dipole, you don't have Q, do you? You just have a dipole, if you see what I mean.
Yeah, I mean, I suppose they do have a Q, but it's not going to be very high.
Yeah, correct.
So is that the way you toast your marshmallows? When you go
Lovely.
Tank or
Yeah.
So for receive purposes only,
Yeah.
you would prefer to use your passive unamplified tuned Alex loop as opposed to an amplified broadband loop for receive purposes only. Signal to noise ratio is the primary concern.
Yes, I mean, yes, you've got to tune the frequency you want and then tune the direction. Whereas a broadband loop, you're not. Yes, you can use, you know, I'll call it a preamp, but no, I have never compared A and B. But I would have said a tuned loop would give you a better signal to noise than just a broadband coil, you know, back to my wooden one. So I would say that is quite broadband, A, because there's no amplifier or any active components, but if you put that into a preamp, you've got to have a pretty quiet preamp to compete with a loop, in my opinion.
You mentioned the word radiation earlier,
Yes.
and with mobile phones they've got a SAR rating, which is the radiation frequencies that's given off. Is there anything like that in ham radio regarding all these different antennas and devices? There must be some sort of frequency levels that are given off by them, and has anyone looked into that or measured it?
I have no idea. However, I will tell you a funny story on that. I used to work for British Telecom, and one of our sites that we looked after was a place called Ace High, which is Coldlow Lane, where there were these dirty great dishes called dropper scatter, where they broadcast, it was mainly telex signals, up into the sky. It bounced off little raindrops over France and went back down into Cyprus, I think it was. So you got a hell of a distance. And I mean, there was an awful lot of power going out of these lovely big dishes. Went up there to work one day, and there were all these ban the bomb protesters, and they were climbing all over the dish. And one of the oppos came out and he said, I'll get rid of them. So he went and stood to one side of the dish and said, Oi, you lot, are you married?
Do you want children?
Do you want your children? Yes. Well, put it this way, what's coming out of that dish is going to cook your balls. And unless you come down now, you won't have any children, ever. I've never seen people jump off a dish so quickly.
Yeah.
You know.
So there must be some known aspect about them. The fact
Oh,
that-
yes.
You know, the serious side of the story
yeah.
that you told, yeah.
But I mean, you
Yeah.
know,
There you go. Funny.
dare I say, you talk to a microwave engineer, people who climb towers,
Yeah.
they are now saying that some of them have had child defect problems because basically it's affecting you. But it's the same as any, you know, radiation that you're getting. You know.
Well, it's like going back in the early 2000s. I used to get trade magazines for
Right.
computers.
All right.
And then they were saying, do not install Wi-Fi in schools. Well, now look what's happening. You know, but it's the lobby money that's, you know, where that's succeeded.
Oh, yes.
But they know the effects. So that's why I wondered. I've just got one more. I was gonna ask.
Fine.
It goes back to my original question was, what is the advantages over having a loop antenna as opposed to the others? You know,
Size.
where would you use it?
Size, basically, where you're living in a, you know, very compact area, or you want to pack it up and go camping or something, you know, you've got this tremendous directional property where you can steer it to where you want to go to, over having a 8-element Yagi in your backpack. I mean, this whole thing packed
so
up
it
into a
fits
nice
in
little
well.
bag
Yeah.
that they give you called Alex Loop. And you know, it's a very convenient little way of carrying a fairly enthusiastic aerial.
So it's narrow directional and portable. Is the
Yes.
thing, two things.
Yes. Yeah. But I mean, you know, the other one
This where you're going to do a hula hoop impression.
Yeah.
you try doing a hula hoop with this, it'll hurt every time the capacitor goes past you, and the other thing, it's really heavy. But I mean, you don't have to when this is sort of, not the halfway house, but you know what I mean. That's a 1-turn loop, that gadget was a multi-turn loop, this is 2 turns. Now, whether there is any advantage in 2 turns, I'm really not certain, but it's another way of getting, I say, a bigger loop in a smaller space. So you've got 2 loops, another nice big capacitor in the middle there, and that's another one of these butterfly capacitors where the centre vanes are not connected to either side of the loop. So you've got 2 state places and then the one in the middle. And it's, you know, central heating piping clips. It's amazing what you can make out of a bit of central heating pipe.
So the reason for having the high diameter pipe is that to
Skin effect.
right?
Well, you
Is
say
that to get the Q down?
yes, partly, but for transmitting, you need the minimum resistance possible.
Yeah.
So you some people say, oh, I've made a lovely loop, and then I've got flexible little bits of, you know, coax sheathing. No, stay. You get the loop, and then flexible little bits of braiding going down onto the capacitor. The trouble is, even though you've soldered it, you need minimum resistance, and I'm talking micro ohms, you know. So the resistance between the capacitor plates, on that one, I would like to think is about 0.1 of an ohm, and that's what you need. You don't want any, even a soldered joint is not ideal, but if you just bolt it together as two bits of metal and a nut and bolt, after a while that will corrode, and that will give you an ohm or more resistance, and that is not going to do your cue any good. That's the whole point. You've got to have, you're trying to aim for this maximum cue, and you can get a very good cue. I can't think of the numbers, but the number 1,000 comes to mind, but it's, yes. But then of course, the other thing you can do is have one of these multi-beam Yagis, and again, they're quite clever. They've got lots of, made of a bit of printed circuit board. I don't know if you can see, but you can see where the different printed circuit copper is, and that is for radio microphones, which is quite useful. So you can point it at your performer, your artist, your talent, and get a better radio signal. But that's another ball game. Right, what else was it? Oh yes, I do have one more loop. Again, this is only receiving, but this was a little mini loop, another one from the web, and you can actually, oh yeah, it is meant for, I can't remember the power, but it's got a tune and an operate button and an SWR LED, so you can tune it to the right frequency, but it makes quite a nice little coil, and it goes out to quite a large one when you unwrap it. But again, you can get some lovely kits that you can experiment with and say, I'm not touching that one, but that one might be quite good. But right, anybody else got any more questions?
Right, well, Chris, thank you so much.
Okay.
For a very interesting.
Very good.
I think I can feel a loop workshop.
Well, what I would say is, can I present you with a loop?
Oh, okay. Thank you very much. There should be enough time for a club project.
That's what I think. That's what I'm thinking. And if you don't want that many turns, you just pull the stuff apart dead easy. Yes, I'm afraid my son works for an electronics firm. When they come to the end of the project, they chuck everything in a skip. He's ever so good, because all you can see is the soles of his shoes. Heaving stuff out of the skip. And then he brings it home to me. Well, not home to me, I mean, he works up in Asia somewhere. But he brings, when he comes to visit, he says, here, Dad, here's more presents, you know.
Okay, so this will go on the club physical assets list. So
Oh!
if anybody wants some,
Shout. Yes.
just shout.
But it's a fascinating subject. Yes.
Really good.
Press the stop button.